All right. So a few things here. Let's see. We did a lot of homework questions last time here, just for the recording here, and I have a feeling someone's at the door. Okay. We did homework last time. Is that right? Yes, we did. 5.4 is what we ended up at, and the question from last time still stands: is where did the plus and minus go from this little equation here? So two things here, two answers for it. First of all is you need a plus and minus because you have a square root. And square root, it's not technically a square root. We call it in mathematics a principal square root or the positive square root. So whenever you see this little guy right here, it literally means you only have a positive answer right here. We good? Once you take it off, if you were to get rid of it, how do we get rid of it? Oh yeah, because the square is right here, right? Okay, once you get rid of it, this whole piece can be a plus or a minus, right? Itself, because there's no square root anymore. There's no positive square root. So that's one answer. Second answer is the fact that this, when you look at the signs and you look all the way around the unit circle, and you keep on making sure the signs match up to where these two would match up, and they match up perfectly. So you sort of like it's a test as you go through all the way from 0 to 360, and you're like, that's so awesome. The signs all work perfectly. Because sometimes in mathematics, the sign works opposite. Is that right? Like if you guys remember from algebra 2 or something like that, right? If you have a, like this little guy right here, graph, do you guys remember graph something like that?
Yep.
This guy is up because it's positive, but over here, it goes off to, it's a minus, right? But it actually has to go off to the right. So it's inside the parenthesis, it goes the exact opposite direction what the sign says to do. And again, that's when mathematics goes the exact opposite way. But in this case, when you look at the signs here, all around the unit circle, the signs match up perfectly. And you're like, yes. Otherwise, then this one would have been, right, the negation of this or something like that, right? Or negation for a certain period of time and then positive for a certain period of time. So all the good stuff here. Okay, we're good there?
I'm a little confused. So the positive, the plus or minus is there in the equation, or it's just plus?
Yeah, the correct sign is there already in the equation itself. So if you were to take half of an angle and take the tangent of it, this would always give you the correct sign all the way through the whole entire 360.
So it's not.
No, there's no plus and minus in there, just the signs work perfectly for the value itself. So there's kind of two different answers to that. We good?
Mm-hmm.
At least in my mind, problem solved. Hopefully in your mind, problem solved. Okay. All right.
We aren't actually inventing that here. People checked it for us, so.
We are or we are not?
We are not actually inventing it.
No. Okay. Let's jam with, so we have all three. I think we have all three formulas, is that right? We're all good to go? Let me jump to this here. Maybe I'll do it this way.
Is there a second one for tangent? I thought you said there was a second.
There were two, yeah. Just want to make sure that we get to.
I didn't find it.
No, your homework question was to find the other one.
I was like, I don't know.
Yeah. Where?
Okay, so let's jam with the other one here. So we found one. Tangent of a over 2 is equal to, and gonna go back just to make sure. No, that's not previous. That's weird. Huh, interesting. You caught the last one here. Sine over 1 plus cosine A. Okay. I'm just playing around with PowerPoint. It's fun. Okay, there's one. That's the one from last time. And we can always multiply by 1. So how about this? Multiply this guy by, and I think we guessed it. Let's see, that was your homework assignment, is that right? To find another one for tangent here. And then I want to see what the back of the book, which one does that give you for tangent half angle formulas? Oh, cool, they do give you both. So back of the book, they give you both here. So we can always multiply by 1 anytime we like. In this case, when we multiply, it's going to be a sine A on top multiplied by that on the bottom here. And then what's on the bottom? 1 plus cosine A times 1 minus cosine A. Anyone? 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 Some kind of from a movie somewhere.
1 minus cosine to the fourth.
Yeah, difference of two squares. 1 minus cosine squared A. Difference of two squares.
Is it not to the fourth?
It is not to the fourth because everything is
Oh,
linear
yeah,
right now,
never
so it's
mind.
only just to the second power. 1 minus cosine squared A is the same thing as sine squared A. Love that. And the signs reduce. Don't need the parenthesis on top anymore because I'm not multiplying by anything. And I have the other formula for tangent, half angle formulas for tangent. All right, and in the front cover of your textbook, they show all 4 formulas there. 1 for cosine, 1 for sine, and 2 for tangent. Tangent becomes a special one this time around. Cool. A few people still writing down. Now we'll get going here. Okay, finally we get to use the formulas here. We have used sine before already though, right? Half angle formula for sine. For cosine, so let me jump up to here, and I think we're all good to go. Let's go with it. So we did degrees last time here, so let's switch to radians. So I need cosine of pi over 8. So I figure since we're dealing with a half angle formula, we should think about what it means if it's doubled in the first place. And so I'm thinking cosine, let me erase that too. Guys, talk to me here. Lights better off. Still falls on me? I'll just check periodically. All right, let's see. What's double? What's double of pi over 8? Hey, I think I like that here. So pi over 8 multiplied by 2. That would give us pi over 4. Do we know that value? If you don't, you're in the wrong class at this point here because we have pi over 4 for a long time. So let's go with it here. So cosine.
Wait, you mean like square root 2 over 10?
No, just the angle itself, pi over 4. We know what pi over 4 is a common angle we have already, right?
Oh, okay. I get it.
And so now let's go with this would be pi over 4 divided by 2. Tell me if that makes sense to you guys here.
Wait, why are you dividing it by 2?
Because I want to get back to pi over 8.
So, wait,
So-
why did you go with
Sure.
Is it because you need to put it in the?
Yeah.
In the formula?
It's the formula, so I want to make sure that it looks just like this. And then I've determined what my A value is. My A value is pi over 4. So pi over 4 divided by 2, it would be pi over 8. All right, all yours. Go for it. I'll give you the formula. It's equals 2 plus or minus the square root of 1. Let's see, for cosine, it's 1 plus cosine A over 2. Give you guys a head start here. minus, right? Given the values here, this would be 1 plus cosine of pi over 4, all that divided by 2, bless you. The only thing I didn't mention is the fact is which sign do we want to use? We are at pi over 8. That's quadrant 1, is that right? That's a small angle, right? In fact, what's the degree angle of pi over 8? 22 and a half, 22.5, which is half of 45 degrees. That's cool. Okay. Cosine of pi over 4, or cosine of 45 degrees.
Wait, so we're just using the plus one, right?
This would be root 2 over 2, and the rest have fun. Are we good? Simplifying that. This is like pre-algebra simplification on steroids. You have to have all the square roots in there, make sure those all work out fine. So common denominator here on top would be 2. So I need a 2 over 2 to simplify that 1. Then what I can do is I can simplify that top all the way through. And that 2 still on the bottom. And then I can put a little 1 underneath it, and then I'm going to change it to a multiplication problem by multiplying by the reciprocal. So see if this makes sense. Are we good there so far? Do I need the lights on so you guys can see what's on your sheet of paper? Are we okay? And I think we're almost there. Let's see, square root of 2 over 4 this time. And then what I can do is I can take the square root of 4, which is just 2, and a whole bunch of 2's everywhere here. But to the Greeks, that was awesome, because they're like, this is the exact answer for an angle we did not know before. They're all excited.
Then would you not write the plus or minus because it's in quadrant 1 and so you know it's quadrant?
Yeah, you have to choose plus or minus from the get-go right over here. You're saying which quadrant am I in, or which quadrant am I going to be in? Because of some of those questions we actually won't know initially. We'll see those. Okay, are we good there? So we have cosine of 25.5 degrees. We found that out. At that point, you could still use the summation formula. We won't go there because we have calculators. We can go from there. But you can now add on 30 degrees to this, which makes, what, 52.5 degrees? Is that right? We can use the summation formula for cosine now to get angles that we would never generate another way, right? We can add now 22.5 degrees to whatever angle we know already. So any multiple of 30, any multiple of 45, we can do that with. Anyways, I thought that's cool. That's awesome. Expanded trigonometry. Okay, so now this is the case. So we start off with just a ratio. We don't know what the angle is. We just know the ratio for cosine, and when I measure it is 3 over 5. And then I also know that angle A, not half of an A, but just angle A is in quadrant 4. Cool. So let's talk about the angle measurement itself here. So let's go over here. We wind up in quadrant 4. If we want half the angle, which quadrant will we wind up in? we're gonna go back to 2, is that right? That's a little chart that we made up last time here. We're gonna go half the circle, so it goes all the way back to 2. So let's see, in this case, I know that sine is still gonna be positive. Cosine theta, well, that's the one that's going to be negative for me. Cool, okay. Let's jam with that here. So in this case, it's going to be a plus for sine. Oh, that's so cool. Because looking at the formula and looking at what ratio I do know, I already know cosine of A, and I can do the rest. So I'll let you guys start on the rest here. Very similar formula, plug in the 3/5. And the simplification is very similar. It's all the time very similar. You plug it in, you get common denominators based upon that 1, simplify the top, change it to a multiplication problem, and see how much you can simplify further. Cool, let's see. I finished upgrading algebra homework yesterday. So I noticed that a lot of you guys submitted a whole bunch of trig homework as well. So I'll be doing that today and tomorrow. Hopefully I'll be caught up. Cool, all right, let's go with it. I put a plus sign just to indicate it's plus, but from here on out, we don't need it. So this comes in as 5/3, and let's go with it. Exactly the same process as before. The 1 changes into a common denominator. Simplify the top. 5 minus 3 is a 2. Oh, maybe that's too much here. Let me do it right here. Just save on space. Everybody good there with that? Change that to a multiplication problem here. So 2/3 now multiplying by 1/2. And in this case, the 2s are going to cancel themselves out. That's awesome. A little bit more simplification. We do have to not have a fraction inside the square root. We don't like that. So reducing this, splitting off the square root, 1 just becomes a 1. Still not nice. We're going to rationalize our denominator. Over 5, I think that's where we end up at.
Wait, I can't really tell, does it go from square root 2 over 5 times, yeah, oh, okay. I thought that was a square root 1 after that.
Gotcha. Everything good there. Your book does this, and we in calculus, we do this too here. Sometimes you really don't need to rationalize your denominator. For sure, you need to get the square root out of the fraction out of the square root, that's for sure. We don't like fractions inside square roots. But your 2 answers are this one right here. So 1 over root 5 was just fine, and this one is just fine. So these 2 would be correct answers. All right, your job for B by yourself from beginning to end. This is going to be, oh, negative or positive? Negative with that one. Go like this here. So don't forget the negative sign in front. And it's a, sorry, we're adding this time. There it is, okay. Give you guys a minute, try it yourself here. Let me walk down and see how you guys are doing. Turn up just a little bit. Too dark. All right, and then you ask me questions if you're stuck anywhere, okay? Or even on the previous one if you're stuck. Something about -2/5 or a -2/5/5, something like that. That's cool. Okay, got about half the people done here. Let me go quickly here. You guys catch up if you don't have it done yet. So boom. 1 plus, we plug in the 3/5. Still part of the same problem. We're still here. And then this point here, this becomes 5/5 plus 3/5 over 2. Adding up the top 3 plus 5 is 8. That's cool. Changing it to a multiplication problem does that for us. And some people multiply the 8 and the 1 and the 5 and 2 makes 8/10. We can also reduce these. And that makes a 4/5. And some people got stuck here just for a little bit. So this one is, you're going to split off the numerator denominator. And we have ourselves a -2 on top, a √5 on the bottom. That is perfect. That is a correct answer. Some of you guys had that answer, and then some of you guys like to still rationalize the denominator. That's fine too. Both are totally okay answers. So that one and that one.
So when you said something like -2/5, you meant exactly that?
It meant exactly that.
Yeah.
I was like, so. root.
Yeah.
Okay, we're good. One last one here, and then the rest should be fine. Tangent, and then cotangent should take you no time at all. For some reason. You have a choice which one you want to use here. I'm going to use this one. If you chose to use the first one, that's cool too. This one I like just because there's plus signs, so I have to mess with the minus signs there. So I chose a second formula, sine A over 1 plus cosine A. Oh, bummer. For this one, I actually have to know what sine is, sine of A, because I'm only given sine of B. So then I have to go back. I'm sorry, I'm given cosine of A. I'm not given sine of A. Shucksaroo. Let me go back one slide. So cosine of A is 3/5. I know we're in quadrant 4, so I have to go back to my triangle setup again. Boom, boom, boom. Here's my A value here. Cosine, go back over here, 3/5. So I got myself this 3, that 5. which gets me that little guy right there. 3 here. And voila. How about Pythagorean theorem again? Nope, I'm wrong. Is that right?
Does the 5 go on the x-axis?
5, no. I think
Yes,
the
that's-
3 goes right here. That's right. Wrong. Sorry. Let's go back real quick here. Cosine of A is adjacent over hypotenuse. So
Right.
the adjacent side should be 3. There it is right there. Hypotenuse is 5. And then we just need to figure out what would be the, still want to make a 4 in there. I'm not sure. Sorry, should be 5 squared. There's my 16 and voila. There's my little,
Wait, so then is it negative because it's in quadrant 4?
which one's negative?
The sign.
The sign value will be negative. We're going to choose which one we want in just a second here. So from doing our formula, should say this, when you take a square root of both sides, we always have to put plus or minus. So the algebra work to it gives us a plus or minus 4. We get to decide that we're going to choose the negative 4. And that's where the signs make total sense eventually right there. Because we are choosing the negative or the positive for our answer. You guys okay with that? Does that make sense? Feel nobody lost? Are we good? Okay, okay, let's jam. I think I got what I need here. So sine value for A would be negative 4/5. 1 plus cosine, I'm giving that was 3/5, and away we go. Common denominator, 5/5, plus 3/5, great. 8/5, and what do we talk about? Did we talk about denominators? If you have both denominators exactly the same, what can we do? We can just cancel them out. We can go like this, like that. That's perfect to do. If you're scared to do that still, and if you change it to a multiplication problem, notice what's going to happen right there. The 5s will still cancel out because now one's on the numerator, one's in the denominator, and voila. And I got myself negative 1/2. Is that right? Negative 1/2.
If tangent is sine over cosine, can you take the solutions for the previous 2 problems and just put them on top of each other?
Absolutely. So let's do it this way here.
That's what I did at first, and then I thought it was too easy.
And I started doing something else, and I was like, okay.
Nope, I was saving it for the next one because we're gonna do that with cotangent here. So let's go back this way, say to ourselves, you know what? That's my answer for sine, √5/5. That's my answer for cosine. So how about just plug it in like this, and let's see what happens here. Negative √2, oh no, negative 2/5/5. There it is. This is, sorry, notes are, this would be sine A/2 on top, and cosine, let me write it over again, because I don't like the way it's written here. So tangent is the same thing as sine over cosine, and absolutely, those ratios hold true all the time. It is part of our identities. And so whenever you want to do that, you can just plug it in that way as well. Once again, just want to make sure I get the signs correct here. So sine, as we got from A, is this. Cosine that we got from B is this. And voila, denominators are gone. I'm left with that. Square root of 5s are gone. And I'm left with the same exact answer. Cool. Now the fun part begins. Let's see, which side of the room should I start on? Not that I'm picking on anybody, but Grant. Grant, what is cotangent?
What is cosine?
Yeah, what's cotangent of A over 2?
Oh, the cotangent of A over 2.
Mhm.
Sine of A over 2 over cosine of A over 2.
Perfect. That's one way we could do it, and that's still too long.
Yeah.
What's an even easier way to do it? Something about reciprocal stuff. I heard 1 over tangent. That's what I heard.
It is,
So then reciprocal of tangent, that's all I need here.
but yeah.
Reciprocal of negative 1/2?
-2.
Perfecto. Love it. I love it when we don't have to do any work whatsoever. So there it is. So
But you can do it the cosine over sine, right?
you could do cosine over sine, and you should wind up with a -2 at the
Oh,
end.
yeah.
Because you're just going to have the -2 root 5 over 5 on top, and then you're going to have the root 5 over 5 on the bottom. But essentially, when you have tangent, why not use that and just take the reciprocal? Cool. All right. I think the rest we can do. Boom. So, Grace, I need secant A over 2. Now, this one may require a little bit of work. Okay, we can show the work, I guess, if we like. I guess we could show the work. Let me start off the work with you here. So the answer we got, the nice answer we got for cosine. Sorry, Grace, I'm gonna do some of the work for you. Is that okay?
Yeah.
Like no student ever said that.
Yeah, it
No,
is
ever.
not okay.
Yes, please. I'm a little lost.
Okay, cosine, we got a -2 root 5 over 5, or we got a -2 over root 5. The first one looks more simple, is that right? That guy seems a lot simpler. So secant is the same thing as 1 over cosine, and the angle has to remain the same. We just got this in part B, and I like the fact that it was -2 over root 5. That's it. If not, then you got to simplify again and all the good stuff here. So this just means reciprocal. That little 1 over the other thing. And so what we do is we just switch them around. 1 over the fraction is really the reciprocal of that fraction. And we're done. That's about as simple as it gets. Now, if you want to make it more difficult on yourself, said by no student ever. Right, you could use the other answer that we got. That was the rationalized answer. And if you do that, then you have yourself now some work on your hands. So we're going to take the reciprocal, and we have that. And then at this point, you do want to rationalize your denominator because you're going to have some more simplification on your hands. So now you have 5 root 5 on the top. Then you have, I just don't want to make it more complicated here. Those guys cancel, and you're still left with the same answer. We good? So it's better to use the non-rationalized denominator. Cool. And boom, all yours for cosecant. Oh, Matthias. Hi, Matthias. Good morning to you. Cosecant A over 2.
That is what it says.
I'm sorry, not wrong.
I agree.
So let's see for sine. Matthias,
I agree with it.
how about this here? I'll give you a choice. Which one do you want to use? The first formula or the second formula?
First, well, which one's the first one? The one with
Yeah,
the
I
square
can't
root
Which
on the
one is
bottom.
the easier one? Then we'll work down from there.
1 over
That's
root
the
5.
one with the rationalized denominator.
You want to use this one?
Absolutely.
Okay. See, Matthias always making things difficult. That's okay. We can do it.
Shots fired.
I do consider
Get
that
right.
my
You might want to
strong
do that.
suit. What do you think Matthias Day is all about?
That
I
was-
haven't seen that.
That
one
was a
yet.
reference.
Did
So
you sign the petition, Mr. Honjo?
I haven't. I'm still on the fence on that.
Oh.
So
Don't be
You know,
silenced by
offense
the
is not a
powers
no.
that be.
Well, I got
Seen
the
that
impression
always
so.
been great.
Yeah, you kind of did. Grace and I peer pressured each other and then peer pressured Brad.
Probably the most surprising
Yeah.
thing I must say.
We were both on the fence and we were like,
I
well,
just
if we
felt
go
like I
down.
was saying no, and so I was like, okay, well.
I
let's go
I
home.
wanted it so bad, but I was like, I don't know if I'm allowed to because of student council, but then
Yeah,
Charlotte
that
had
was
signed
my-
it,
that was
and then I was like, if Grace signs it and I
If we all
signed
do
it.
it, then it's fine.
Oh, so did you? Okay, gotcha.
So we all signed it.
Like literally. it's
So if we're going down, we're going down together.
Okay, we're good with Route 5. So the easy way to do it, the non-Matthias way to do it would be run over one. Would be like this.
The world would be
Actually
non-defined.
You can literally just, yeah, the non-Matthias one is literally.
Flip it. There you go. And you are done at this point right here.
Oh, nice.
But no.
Fun.
You're on the Matthias route.
Okay, we're good there. So once you get sine and cosine, you can use the tangent formula if you like. You can use the ratios and then just use the other ratios to finish it off. So you guys will have homework questions like that. Okay, so got some other ones to finish up, I think.
I don't have it.
Run fast, you have long legs.
You actually don't want to run. You'll get wetter.
Is that true?
Yeah, Mythbusters proved it.
Oh, wow.
Wait, what?
You're gonna get what?
The faster you move, the wetter you get.
Oh,
What?
But I imagine if you moved really
Yeah,
slowly,
there's
you
some
would
sort of-
also.
Yeah.
What you should really do is
There's
just
probably
stand
a
still.
threshold,
Yeah.
like a speed threshold. If you
Like
move
walking
at-
versus
if
running.
you move at 99%.
Crawling along the floor.
what example are we on?
I'm sure you wouldn't get red if you
Guess
ran
what, manage to
99%.
like slow down time so that you can walk slower.
Yeah, if you
like,
ran
you'll
99%
be
of
all
the
right,
speed of light.
also.
That's
Right.
so they still end up hitting you
you.
because I don't think you can
Well,
avoid
yeah, you would never
Yeah.
see them in the
If you
black.
ran
That's
99
possible.
That's true.
Right, if you ran 99% of the speed of light, you'd be very dry because of the resulting. Because you would be just
You wouldn't.
Yeah, and you'd cause a thermonuclear explosion.
Yes, that as well.
Yeah, that would probably incinerate most of the rain. Well, not
If
incinerate.
you don't want to get dry, just learn to left the bottom.
Yeah, exactly.
Okay.
all right.
So the best way to I mean, thermonuclear explosions do really mess up weather, so you probably dry. Yeah, and you'd be dry.
You're
for at
really
least a little
dry.
while.
You'd be very dry.
I don't think you get.
All right, let's go with it here. So two more problems to go. So graphing this guy, I need to graph 6 cosine squared x over 2. No. Graph that one. And so this one looks complicated. It has the half angle inside it. It would be squaring things as well. So I'm wondering if there's a possible way to simplify it some way, somehow. And so maybe we go through this little process. I do want to finish up one more and kind of show you something else as well here. So cosine, half angle for cosine. And it's going to be squared. Whatever that thing is going to be, it's going to be squared. So in this case, we can put plus or minus if we like. That's going to undo itself anyways. But cosine formula, half angle formula, plus or minus, which one does it have in there? Is it 1 plus cosine x or 1 minus cosine x? 1 plus, okay. I'll go with it. I trust you.
Nice.
I'm more trusted than you.
I was gonna say.
Yes, it is.
It is,
I
okay.
think most people are more trustworthy.
So if you square a square root, what happens? It goes away. That's awesome. This is what I like here. So that guy and that guy cancel. I am left with just this right here. And the 6 and the 2 can reduce finally. So I'm left with something looks like this. And then if we wanted to put it into graph form, like that. And can you guys graph this guy? Something about amplitude change and something about a vertical change. All right, let you guys do that. All right, so see, I have an amplitude change and it's 3. So we're gonna go 3 up, 3 down from the middle. The period has not changed. It's still gonna be 2 pi, no phase shift either. I just have a vertical shift. Vertical shift, we're going up 3. So let's see, thinking about this here. In fact, I'm gonna go this way, but then I'm gonna raise this up a little higher. So 1, 2, 3, 4, 5, 6. I want to go up to 6 for some reason. And then I'm going to go out to 2 pi, which I have to, but then there's no change to my period, so that's nice. So I'm going to just cut this in half, and then cut it in half again. So I need 4 pieces here. Pi over 2, 2 pi over 2, 3 pi over 2. Thinking in my mind of the cosine value there. Now it's going from, instead of 1 to -1, now it's going from 3 to -3. In my mind, that okay? And I'm going to shift this whole thing up 3 units higher. So instead of starting at 3, we're starting at 6. By the time we get to pi over 2, we're still shifting up 3 units. So we're going to be right here. We're going to be actually at 3. As soon as we hit pi, we actually hit the 0 marker. There it is. And then we go up to 3 again. And then by the time we hit the 2 pi, we're at 6 again. So it should look.
We strive only for perfection with our graphs.
Same here. Uh-oh, it's starting to rain more now. It stopped while we were in class. Oh, yeah.
Literally can't find it. I think it only rains like 2 days.
Yeah, it's the 2 days that we can't find.
Yeah.
I was wondering
One of
if
those days, like, school was canceled.
I know, I was wondering if you were gonna get an email saying school was canceled. I was half wondering.
I
was
looked
like,
it
I
up
wonder
as
if
well.
they're gonna say it's a sick day. Yeah, well, we'll be shaking so much because we have a recitation, so it'll be fine.
Oh my god, last year I said it, it was like perfect, and then this morning I like said it, right after I got up, so I was kind of tired. Well, I was really tired, and I like could not.
And that's always the way it works for me. I'm like, I promised you last night, this was really good.
Yeah.
One more problem. Let's go. One more problem. We'll be done. We have a prove identity with half angles inside them here. So let's see what we get to. And so let me do this quickly here. You guys think as we go through it here. So cosecant definitely will turn into a sine. I think I'm going to have to figure out what that's going to look like. And then secant will turn into 1 over cosine. So I'm going to have to do, looks like 2 sides to do here. So this guy will change into 1 over sine squared a over 2. This guy, how about 2 over cosine of a? Oh boy, and this is also going to be 1 over cosine a minus 1. So I think I'm gonna have to work both sides out. I noticed that the right-hand side doesn't have an a over 2, it just has a. So at this point, I think I'm gonna simplify the left side back to what we did previously, actually on the previous one. This would be the square root of, again, plus or minus, so we're gonna get rid of it anyways. Cosine a over 2, and this will be squared. On this side,
Wait, so then can't you just like automatically erase the square root thing?
yeah, I'm just showing you one more step here,
Oh, okay.
but eventually, yeah, you can just erase the square root. On this side, so let's go one step further, just to 1 minus cosine a over 2. Hey, that looks like reciprocal again, doesn't it? 1 over something means it's going to be reciprocal of that something. And so I'm done on this side. That's about as simple as I can get right there. Square root canceled. I took the reciprocal, done. On the right side, let's see, I guess I need a common denominator right there. This I'm going to choose to be cosine a over cosine a. Is that okay there? Make it a little faster. And I think what's going to happen is 1 over cosine a minus cosine a over cosine a. Oh, love it. Okay, I see where I'm going now. And so cosine a there, this would be 1 minus cosine a over cosine a, because I've simplified that little bottom there, and denominators cancel of complex fractions. Love it. And with the rain, I'll just write QED. Oh, look at that. It stopped raining. It just scared you for a little bit, and then it died
You
down.
know it's gonna come back.
No, I was
like
like,
outside.
thank you, God.
Yes.
It said to run to your next class before, but hold on, Matthias said if you run, never
No,
mind.
it's gonna like dump here.
Yeah,
and then,
it's
like,
gonna dump
right
after
after
history.
we all have like to walk down.